I'd like to take a moment now to summarize the different electrical quantities that we've studied up to this point and the relationships between them. All right, so the first one that we started with was electric force. So recall that a force is just a push or a pull. These are familiar from 121, and they have units of newtons, for instance. And essentially, all we have done is noticed that there is this new phenomenon which allows there to be forces between different objects. Okay. Through doing some experiments and some investigations, we found that the force seems to be determined by a quantity called charge. So a charge is a property of objects. It's sort of a physical property. We don't directly detect the charge. What we detect is the force that's caused by the charge. We found that there appear to be two different types of charge. We found that the distance between the charges also affects the force, but the charge is this physical property. So electrons have a certain amount of charge. If you rub a balloon on your head, it gets some amount of charge on the balloon. Okay. We also had electric field, and we had two different ways to think about the electric field. So one way to think about this is, what would the force be if a test charge were present? Okay, so it kind of takes the idea of a force, but makes it a property of one charge instead of the interaction between two charges. The other way that we could think about the electric field was that we could think of it as the invisible agent that transmits electrical interactions. So we sort of imagine that an electron is carrying this infinite structure around with it, and when an electron pushes on some other charged object, it's because that structure has, reached out to that point, and there's either an attraction or a repulsion in response to it. Okay. So the new one that we have just introduced is the electric flux. And the way that we are thinking about that is that it is the amount of electric field through a surface. Okay, and mathematically, the formula for this is that the flux is E dot A, or we can integrate if we want to. All right, so these are four different quantities, and they're all different. So if any of these sound like the same thing to you, you want to definitely make sure that you figure out how they're different, and you can explain at least to yourself what the interactions are between them. Okay, so what are the interactions between these? Well, the starting point that we had was that we have charge, Q, and that is related to the electric force. Okay, so these two are related by Coulomb's law. The increasing charges increases the force between the charges, and so on. Okay, so those two are connected in that way. The force is related to the electric field by the definition of the electric field. Okay, so electric field is just defined to be the force divided by the test charge. And so it's proportional to the force. The electric field is bigger if the force is bigger and smaller if the force is smaller. So that's the relationship between those. Um, the last quantity that we have, the one we just introduced, is the flux. And the relationship between these, well, the definition of flux originally was related to the electric field. So the flux is equal to E dot A. So the area is just something we made up. It's this, structure that we draw on the diagram, and we can calculate the amount of electric field passing through that, and that quantity is the flux. Okay. But the thing that makes this interesting and makes this come full circle is that there's a relationship between the charge and the flux. Okay, so that relationship is Gauss's law. So Gauss's law, remember, tells us that the integral of E dot dA is equal to Q enclosed over epsilon naught. Okay, so it turns out that the amount of flux through a closed surface only depends on the amount of charge that's enclosed. So the way that we went through this was starting in the upper left and then going clockwise. But now we see that we could also go the other way. So you could start with the charge. Notice that this quantity flux is going to be the same if you enclose that charge no matter what, and from that you'd be able to find the electric field and find Coulomb's law. So this thing works in both directions, which is why I drew those arrows double-sided. There's a lot of connections here, and you should think of this more as a network of interrelated ideas rather than each one follows from the other. You could start in different places and end up with the same results.